Leetcode practice time. In this video there are two goals. So the first goal is to see how to solve this problem, and then we are going to put some solid code in, and the second goal is to see how we should behave in a real interview. So let's get started. So in the real interview, remember the first step is always try to understand the question. If there's anything unclear, please bring up the question to the interviewer, and also at the same time think about some edge cases. So let's read through this problem. So transformation sequence from word begin word to word end word using a dictionary word list is a sequence of words such that the first word in the sequence is begin word and the last word in the sequence is end word. So only one letter is different between each adjacent pair of the words in the sequence, and every word in the sequence is in word list. So given two words begin word and the end word and the dictionary word list, return a number of the words in the shortest transformation sequence from begin word to end word, or 0 if no such sequence exists. So let's see this example. So hit to cog, so it is going through hot to dot, who dog to lot to log to cog. Alright, so we don't count the first transformation into it, I guess. Okay, let's see. The sequence is from hit to hot to dot to dog to cog. So we have 5 words within it. Okay, so we do count the begin word in the changing sequence. So let's say if there is no possible transformation, then it is going to return 0. But what if the begin word and the end word they're the same? So if they're the same, I guess we need to return 1, I think. So let's see. The begin word is between 1 to 0 as 1 to 10 as a length, and the begin and end word has the same length, and also the word list contain more than one word and no more than 5,000 words. And all the words has equal length. And other words are just lowercase English letters. And the begin word is not equal to end word. And all the strings in the word list are unique. So I think until now we have a good understanding about the problem. I don't really think there is a obvious edge case here due to the constraints. So let's start with the next step, which is about finding a solution. So how to solve this problem? So I would say this seems to be a BFS question, but what makes it different is we need to add an extra step to build the graph actually. So the graph is actually, we define the node as a word and the edge between a pair of the words. So an edge exists as long as two words has only one character of the difference. So we could go through the word list and then build a graph. So after building the graph, you can apply some BFS on top of it to find the shortest path from the begin word to the end word. So let's see if the begin word and end word are going to exist within the word list, because if the begin word or the end word they don't exist in the word list, then for sure we should return 0 here. Alright, so let's get started and do some coding work. Okay, alright, so before doing the coding work, let's do some runtime analysis. So for this one, the runtime is mostly about building the graph. So let's say we have n words in total, and each word has the word length as L. Then the total runtime is, because for each word we need to go through all the possibilities for each of the letter and see if after replacing the letter there is a corresponding word within the word list. So for that one, it is going to take an L but after replacing the one character, it takes about L runtime to generate the whole word. So I would say the runtime is O N L square. Actually, it is just O N L L. Yeah. So that's pretty much about the runtime. Then let's do some coding work. So for coding, we care about the correctness of the code, the readability of the code, and of course, don't be too slow because there's the limitation in the coding interview. So let's get started and give it a shot. So the first step is about, so let's see. So let's see, the first step is about building the graph. But before that, do we really need to tell whether the begin word or the end word exists in the word list? Yeah, so let's see. Let's define some helper function here. Let's say we have the list to set. So this one is going to return set of the words. Let's say list to set. So it is going to pass the list of the string as word list. Goes through every the word within the word list. Let's say define a set of the words. Say this is word set. Yeah, sorry about the sore throat. Yeah, I think I have some dry throat at this moment. So word set dot add the word, and then finally we are going to return the word set. So we will transform the word list into the word set. At this moment, is equal to list to set on the word list. So if the begin word or the end word doesn't exist in the word set, then we are just going to return 0. If not, word set dot contains begin word, or if the word set doesn't contain the end word, then we are just going to return 0. Otherwise, what is the next step? We are going to generate the graph. So let's say we are going to generate the graph. It is going to be map from the string to let's say it is to a set of the string. Yeah. So this one we call it build graph. What we are going to do is we are going to pass in a set of the strings here. So first of all, we need to define the graph we are going to return. So this is string set of the string. This is a graph new hash map string word word set. Yeah, so what are we gonna do? We will need to go through each of the character, try to replace the character with another character, and see if after replacing the character the word still exists in the word set. So we are going to say graph dot put the word and new hash set. And for each of the so do I need to turn it into a call array? I think. So let's say call array is equal to word dot to call array. 0 is smaller than cars dot length plus plus I. So if let's say original car is equal to cars I. So we are going through the all the possibilities. So for car C is equal to, it is from A, and C is smaller or equal to the lowercase c plus C. So let's say if the C is equal to original car, then we actually just need to continue, because if it is the same, then potentially it's just pretty much the original word, which we don't need to add into its neighbors hash set. Otherwise, we are going to set the cars I as C, and we are going to bring all the characters together as a word. So this is, let's say, neighbor as is there any car array to Java car array to string? I think there should be some helper function there, but I just do not remember that. So convert car arrays to string. Okay, so this is new. Okay, so there really is a helper function there. So neighbor is new string. There really is the constructor there. I mean, so this is a neighbor. So if the word set dot contains the neighbor, then we are going to have graph dot get the word. So the word dot this is add, I think, add the neighbor, and after this this inner for loop, we need to set the cars I as original car. So I think that's pretty much it, and we finally just return the graph. So let's take a look at this one. So we build graph, we iterate through each word within the word set, and we put the begin for every of the so we put the word and the corresponding hash set to make the neighbor list for the word, and we break down it into different characters go through each character and see the corresponding replacement. If there is a way for us to replace the character, then we are going to replace it and construct a new string, and if the string exists in the word set, we are going to add it to the neighbor of the word, and then we are going to, after this for loop, we are going to change the original car back to the car's I. Okay, I think it looks fine. So that's the first step, which is about building the graph. So let's say the first step, string set of the string. This is a graph is equal to build graph. It is a word set. So after building the graph, it's more about the BFS stuff. So for BFS, it is about the queue. So for the queue, you're going to have a string, new linked list as the underlying implementation. And let's say so let's say the distance is starting from 1. Let's say starting from 0. Then the queue, we start to put the begin word into it, and then it is the rest of the logic is about BFS. So while Q is not empty, so we are going to size as equal. So the current size of the queue is equal to q dot size. We are going to get the size of the queue, and then we are going to iterate through the current layer. And so current layer, so we are going to plus the distance at the very beginning. So I is equal to 0, I is smaller than size, and plus I. So this is a string, a word is equal to what is this? So this is q dot pull, I think. So we are going to get a word and get its neighbors. So I think one optimization we could do here is we could record the visited, the string we have already visited. So let's say we have a set visited as a new hash set. So we are going to find all its neighbors for this word. So string neighbor for graph.get word. So if the visited already so if visited already contains the neighbor, then we just need to continue because we have already visited before, and otherwise we will add the neighbor into visited. And then after that we are going to we are going to add it into the queue. So queue dot add the neighbor, and within this, I think one thing we need to do is if the word dot equals, so if the word is already equal to the end word, then we just need to return the distance here. So otherwise we are going to return 0 at the end. And that's it that's pretty much it about this question about the coding part. Let's do some testing. So usually for testing you will need to go through a simple test case, explain how this piece of code is gonna work, and do some sanity check to see if there is any bug within the logic, and at the same time fix it. So let's go through this piece of code. So first of all, we build a list, the set, from the list to the set. I think it's okay. And if it doesn't contain begin word and or the end, or it doesn't contain the end word, then we are going to return 0. Let's see that for the example we have hit, cog, and we have this kind of those listed words. We have the cog and hit in the word list, so it doesn't matter for this branch. And then we are going to build a graph. So for the graph, we have an empty graph at the very beginning. And for each word within the word set, we are going to put the word and the new hash set into it. Let's say for the hot stuff, let's say for hot, we will have hot and with empty set. And then we are going to go through every of the character for the hot. Let's say for H, we are going to try to replace it with A to Z except for H, and see if there's anything within that. So for this we have the dots. We have the dots, which is first and we have the lot, and we have, okay, we don't have any more. For the second one, we replace the O to see if there's anything matching. I don't think so. For last one, we just replace the T to see if there is anything missing, anything that could match any of the word within it. I don't think so. Yes, so yeah, I don't think so. So yeah, so that's pretty much it about the neighbors for hot. And similarly, we will do find all the neighbors for dot, dog, log, etc. Yeah, so I think this piece looks fine. Let's see the next piece, for which is the BFS part. So we have the visited, we have the queue, we have the distance. First of all, we add hit into the queue, and then we iterate through this layer. So if the word popped from the queue is equal to the end word, then we just return the distance. Otherwise, we go through all of these neighbors within the graph. If the node we have is already visited, then we just continue. Otherwise, we mark it as visited, and also we add it into the queue to further traversing. But I think overall it looks good. Let's do some give it a shot to do some typo fixing, etc. So I is equal to 0. Okay, so there is a semicolon here. Okay, so it's wrong answer, white is wrong answer. So the output is 0, but expect is 5. So yeah, that's rather weird. So let's see. So first of all, we put the begin word here. Pull it if it's equal to the end word, then we return the distance. Otherwise, we will go through all those neighbors for the word, and yeah, I think it looks okay, but I don't know. So let's first of all, let's output the graph to see if there's anything that can catch our eyes. So the graph, let's print it out. So there really isn't anything. How can that be? So let's print it here. Here. Still there really isn't anything here. Let's see why. So this is a graph. So we call the build graph passing the word set. So the word set, new hash, so go through, going to add the word into word set and then return the word set. Yep, and then if it doesn't contain the begin word, or it, oh okay, so if it doesn't contain the begin word, it's totally fine. I see. Okay, so if it doesn't contain the begin word, it's totally fine. But if it doesn't contain the end word, then it is not good. Yeah, I guess that's the thing here. Yeah, and we also need to, because the begin word is not here, we also need to add the begin word into the word set. Add the begin word. Okay, I think that should be able to solve the problem. So if we add the begin word, we should be able to build a graph, and then we should, yeah. So that solved the problem. Essentially, it doesn't require the begin word to exist in the word list, and if it doesn't, then we need to add the begin word into the word set to build the whole graph. So let's do a submission for it. Okay, yeah, it seems like everything works well now, and that's it for this coding question. So if you have any question about the algorithm or about the puzzle, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.